All right, so this is the last part from the chapter 5 and chapter 4. From this chapter, you probably remember the last class we were talking about a simplification technique for the logic expression, Boolean expression. So the name of that technique is called kernel map. Okay, in short, that is called K-map. Now, remember we learned about the Boolean rules, and using the Boolean rules we can simplify the expression. So, which is fine. I'm saying we can simplify expression using the Boolean rules, but this is a similar. This is another technique for doing the similar, for doing the similar thing. Okay, because we can do simplify the expression using kernel map, but we don't need any of the rules. Okay, so even if you don't know the rules, you can still simplify it using the kernel map. Okay, so this is like another technique, but this is also important to understand. And let's talk about this first. So in this case, what we do is, to give an overview, we draw a table. Okay, to simplify it, we'll learn how to draw the table. So, but mostly this is what we do. Based on the expression, we draw the table. For an example, if we have 3 variables in our expression, we draw a table with 8 cells. Why it is 8? It's 2 to the power 3. Okay. If we have 4 variables, we draw a table which is 2 to the power 4, meaning with 16 cells. Okay, 4 by 4. So we actually will learn how to draw that. Okay, how to do all of those, and how to put the expression, and then how to find the simplifications for sure. Okay, now if you look at the table that you have here at the right side, it actually give you a little bit interesting idea about the kernel map. If you look at all these expression that we wrote there, look at very carefully. We actually have written all different combinations of ABC. That means, let's say if I'm given ABC, how many different ways I can write ABC with their primes? You know what I'm saying? For an example, I can write ABC, I can write A prime BC, I can write A B prime C, I can write ABC prime, I can write A prime B prime C prime. I'm saying, so there will be at max like 8 combinations. There is no way you can write more than 8. Now this is exactly, these are all those 8 combinations. But there is a little bit tricky, because if you look at more carefully, if you see between any adjacent cells, like the cells that is near to each other, there is only one change, not more than that. For an example, if you look at here, this is what? A prime, B prime, C prime, right? Look at the rightmost one. The only change is what? C, right? You see it? Because A prime, B prime is same. The only difference is C, which is changed. Now, again, if you look at the very adjacent here, the only change is B, right? Now, if you look at here, look at this. Between this one and this one, there is only one change, which is C. If you look at this one and this one, there is only one change, which is B, right? Because there is B prime and there is only B. So pretty much if you look at the whole table, is always one change between any adjacent cells. That means this is actually possible to draw a table like this, right, for any combination of ABC. And this is also possible if you have even more than 3 variables, like 4 variables. We'll show you how to do that. Okay. Now, to understand how to find a table like that, we make it a little bit, simple here, because what we did is, this is what we do. Let's say we have 3 variables, right? We just wrote AB for this column, and for the 3rd variable, we have C along this line. Now, if you look at here, for any variable, it can take only 2 values, right? So for C, we can have either 0 or 1, right? That's what we did. And for AB, we can have 0, 0, we can have 0, 1, we can have 1, 1, we can have 1, 0, right? All combinations. Now, if you look at again carefully, these are something like binary numbers, right? So this is binary 0. This is what? Binary 1, right? This is binary 3, and then this is binary 2. So you might be wondering why I did that, meaning I should have written 0, 1, 2, 3, but instead I wrote 0, 1, 3, 2, right? Instead of writing 0, 1, 2, 3, I wrote 0, 1, 3, 2, because if you look at here, this is actually 3, and then next one is 2, right? So basically 3 appears before 2. This is actually for the same reason. Remember I said between any adjacent cells, you can have only one change. Now here is the problem. If you write 0, then it is 0, 0, right? If you write 1, that is fine, because that is 0, 1, so there is only one change, right? But if you write after 2, if you write, I'm saying after 1, if you write 2, there are 2 changes, right? Because 1 completely flips if you write 2, because 1 is 0, 1, 2 is 1, 0. So both of the bit gets flipped, right? That's why we cannot write 2 after 1. So instead, what we did is we write after 1, we write 3, so there is only one change, and then after 3 we write 2, again one change, because we cannot have more than one change between any adjacent cells. Okay, but if you do that, it's really simple. Now then, okay, so we are done with the column, and at the top we are done with the row. But what does this cell represent then? Each cell represents a combination of ABC. How do I find it? It's actually very simple. So, very simple. So for this cell, the combination is what? Look at this. Your A is 0, B is 0, and if you look at the top, C is 0 here, right? That means this cell should be the cell for, I'm sorry, yeah, let's go back. This cell should be the cell for A prime, B prime, C prime, right? Because all of those are 0. If you look at this cell, what would be the combination? A is 0, B is 0, but C is what? 1, right? So basically the combination would be A prime, B prime, C. If it is 0, then it's prime, okay? So if you pick this cell, what would be the combination? If you look at the left side, 0, 1, right? Meaning A is 0, B is 1, and C is 1. So the combination would be A prime, B, C, right? So that's how you can pretty much pick, And then if you pick, any of the cell, it actually picks any of the combination of A, B, C, and that's how you will actually cover all the combinations of A, B, C if you pick all of those cells, okay? That means in the Carnot map, we first draw a table like this, which is also called map. And then we know exactly how to order it, right, along the column, and how to order it along the row, right? So again, and sometimes instead of writing 0, 0, 0, 1, 1, 1, 1, 0, we can write like this. It's exactly the same thing. Look at this. This stands for 0, 0, right? Meaning A 0, B 0. This stands for 1, 0. I'm saying 0, 1, right? And the next one stands for 1, 1. See, it's exactly the same thing. And the last one stands for 1, 0 for AB. So sometimes we write using 0, 1, sometimes we write using this one. It's actually the same thing. So I'm saying it's up to you which one you feel comfortable with, you can just write it. So this one is 0, this one is 1, same combinations. It's like, same thing. Now, once we are done with these, as I said, every cell represents a unique combination of ABC. Now, I have 2 different cells highlighted, okay, in yellow. Can you tell me what will be the combination for this cell? What is this cell? A prime, B, C prime, right? And what will be this cell? As you can guess, like A, B prime, C, right? How do I know it? I actually got A B prime from here, right, from my row, and I got C from here, right? And for this cell, I got A prime B from left side. You know, that's how I always get it. And I got C prime from the top side, right? So I get something from my row and something from my column, right? For every you know, combination. So similarly, for every cell, we will have a combination. Any question up to this point? Okay, let's move on and see. So what happens in Carnomap, this is how actually we start. Given an expression, we draw a Carnomap and we put ones on the cells, corresponding cells. Now this is how we do it. For an example, let's say this is an expression given to us. Okay, this is our expression which is given to us. And we will use Carnomap to simplify it. Now before we start, let me remind you something. Remember in the last class we learned about the SOP, meaning standard sum of product, like how to write expression in standard sum of product. And then we also talked about standard SOP, right? Now this is actually standard SOP. That means in standard SOP, your expression will be given in terms of sum of product, because every single term here is a product, right? And this is given in terms of sum of those products. And also, if you look at the expression carefully, this is a standard SOP, because remember what is the property of a standard SOP? In the standard SOP, with every term has all the variables, right? We have 3 variables, right, in this expression. If you look at every term has A, B, and C, right? So that means to start with the Carnomap, your expression must have to be in standard SOP. If it is not in standard SOP, we have to convert it to standard SOP first before we start. Okay, and that's why in the last lecture we first talked about the SOP and standard SOP before we started the Carnomap. Okay, now to make it simple, let's say this is a standard SOP expression which is given to us for simplification. Okay, this is given. Now here is the first step. In the first step, I look at the expression and then I look at the terms. Let's say this is my first term, right, which is A prime, B prime, C prime. Look at the table. What is the cell for A prime, B prime, C prime? This is the cell, right? Is this the cell for A prime, B prime, C prime? So I put a 1 there. Okay. Look at the next term, which is A prime, B, C prime, which is this one, right? So I put a 1 there. So what is the last one? Is A prime, B, C. Obviously this is this one. So basically what we do is, based on the expression, we put 1s in the corresponding cells. This is the very first step. Okay. Any question up to here? So just look at the expression, and from the terms we put 1s in the corresponding cells. That's our first step. You might have more than 3 1s, depending on the expression, right? In the expression, if you have 5 terms, then you will have 5 1s in 5 cells, depending on the expression. Okay. The next step is we basically group the 1s. We make group of 1s. Okay. Now, if you look at here, how do you make the group? We make a group of 2 1s here, right? Again, group means what? Group means you have to make you have to put 1s in group, right? Now, the way you make the group is like this. You can make a group of 2 1s, 4 1s, 8 1s, or 16 1s. These are your choices. Now in this case, 8 would be the max, because 8 means you have 1s with all the cells, but you don't have 1s with all the cells, right? So you can make the group of 1s, okay? And between the groups, you can have overlaps like this. Look at this. You made a group of 1s here, right? two ones, right? And then you made another group of two ones here, and this cell is actually common, so it overlapped, right, between both cells. It's possible. So, and then you read each group of ones and write an expression for each group. For an example, I actually have two groups of one here, right? So for each group, I'll have a separate expression. Okay? For each group, I'll have a separate expression. Now the group that I have at the column level, how do I write it? So what we do is, look at this group carefully. If you look at this carefully, tell me what is changed here. If you look at the left side, what is changed? Look at this. A is 0 here, right? A is 0 here as well. So A is not changed. But look at this. B is changed, right? And how about C? C is same for the column, right? 0. So basically, there should be something which is changed. And whatever is changed, you eliminate it. Whatever is changed, that's eliminated, okay? So what is not changed? A prime, right? Because A is 0, B is 0. And also C is not changed, so that which means C prime, right? So that's why this group is read as A prime, C prime. Let's look at the other one.
I got a question. So
Sure.
you just count what's in the map, you don't count what's on top of it. And you say C doesn't change with 0 or 1, so you just count what's inside of the map, not the 0.
We actually look at the group, right?
Yeah, so that's what I'm saying, you just look inside.
Yeah. For an example, for this group here, for this group, look at the left side. Your A is 0, B is 1. None of these are changed because for the both cells that is true, right? But if you look at the top, C is actually changed, right? Because for this group, C is 0 here, C is 1 here, right? So that means, since C is changed, that is eliminated. So that means this group is read as A prime B. Why A prime B? A is 0 here, right? So that means A prime. B is 1 here, that's B, right? So that is true for both cells. But since C is changed, C is eliminated. Anything which is changed gets eliminated for both cells. So my vertical group is read as A prime C prime. My horizontal group is changed as A prime B. So once we have those individual expression for each group, the next step is we just add them. So A prime C prime plus A prime B. That's my simplified expression. It's actually simple because remember in the previous meaning the Boolean rules, what do? We just take common factors and apply the rules, but at the end you get the simplified expression. But even if you apply the Boolean rules in this expression, you will actually come up with the same simplified expression, because no matter you use Boolean rules or Carnot map, your answer would be same. So the step is, you will be given an expression. From the expression you have to fill the cells by ones, and then the next step is you will make group of ones. But there are some restrictions, because group of ones can be made like this. You can make a group of 2 ones or 4 ones or 8 ones or 16 ones. That means you cannot make a group of 3 ones, or you can make a group of 5 ones or 6 ones or 7 ones. Okay, there are some restrictions. Okay, now I'll tell this later, but let me clarify a couple of things. When you make a group of ones, what is your objective? Your objective is to maximize the size of ones. That means if you can make a group of 4 ones, you'll be just making one group of 4 ones, okay, instead of making 2 group of 2 ones, because you always want to maximize the size, make it bigger, okay, if it is possible. Okay, for an example, in this case we didn't have any other choice, because he can make like group of 4 ones, because you don't even have 4 ones. Okay, let's see some of the examples. Okay, but before I move on to the next examples, if you have 4 variables, how do your table look like? Because you will have two variables along this line just like AB, and the other two variables will be along this line which will be CD, and in the same order. Remember how we wrote AB? 0 0 0 1 1 1 and then 1 0. Same for the row. This is 0 0, right? C prime D prime. Then this is 0 1, right? Then this is 1 1 and then 1 0. It's the same ordering. I'm saying, just to make sure, because we just have looked at 3 variables until now, but this is for the 4 variables. Okay? And in pause and in this class we'll be mostly working on 3 or 4 variables. Okay? Okay. Now, in case of 4 variables, let's say this is something I found from the expression. Okay? I did not write the expression here because my main objective right now is to show you how to simplify the expression, meaning how to make the groups. Okay? Let's say this is something which are given to us. How do you make the groups? That's actually important, right? Because if we know how to make the groups, we can simplify it. Now, as I said, you can make group of 4 ones, right? You can make group of 2 ones. You can make group of 8 ones or 16 ones. Here we have 16 cells, but you don't have 16 ones, right? So how do you make a? Can anyone guess that how many groups we will have here? Just looking at this one. How many groups? 8? Because you. How many groups you said? Remember, we can make group of 4 ones, right? So as you can see, we have 4 ones here, right? Okay, so here is a group. Yeah, so this is how we actually make groups. We actually can make 2 groups. One is this green group. You see the green ones? One is the yellow group. But the yellow group is a little bit interesting. How did they make the yellow group though, right? Because those ones are not, they don't look like they're neighboring to each other, right? Now, this is the reason. Let me show you something. For an example, let's say this is my Carnot map, the paper, okay? Now, both of the sides of the paper are actually adjacent to each other because this is how we think. We think they are actually connected to the sides, okay? They are also connected to the top and bottom, okay? So basically, the left side and right side are actually connected because we think like they are wrapped up like this, okay? So if you have something at the left side and something at the very right side, they are actually adjacent to each other. And if you look at carefully, they only have one change. Remember, between any adjacent cells, there will be only one change, right? They actually have only one change. So that means this to 1 and this to 1 makes a single group of 1s. Now remember, as I said, again, remember, we have to maximize the size of the group, size. Meaning, instead of making 2 group of 2 1s, we make a 1 single group of 4 1s. It doesn't matter because we always want to make it bigger, the size of the group, okay? That's why we are happy with 2 group. We don't want to make like 4 different group here because somebody can say, oh, I just make 1 group between these 2, I can make 1 group between these 2. But no, we just want to make 1 group of 4 1s instead of making 2 group of 2 1s, okay? Because if you make a mistake, like instead of maximizing the size of the group, if you maximize the number of the group, your expression will not be, and I'm saying your simplification will not be right, because you'll probably find something which can be simplified again, okay? You want to get something which is the simplest, right? It cannot be more simplified more. Okay, any question here at this point that how did I make this group? So I have 2 groups here, right? The green and the yellow. So what happens is, once we are done with the grouping, we write the expression, right? So basically we write one expression for each group. So we write one expression for my green group, we write one expression for my yellow group, right? 2 expressions. You have a question? Okay. So how do I write the expression? Remember, the same way, right? Let's say when you look at the yellow group, what is changed? If you look at here, so yellow group actually spans over these 2 rows, right? What is changed along these 2 rows? B is changed. Remember, what is changed? That is gone, right? That will be eliminated. And what is changed along the column? Look at this, C changed, right? C is changed. See, the C is 0 here, and C is 1 here, right? No, only, C is changed only on those column, right? Yeah, we only look at the columns, okay? So the C is changed here, B is changed here, so B and C will be gone, right? So what is common? A prime is common here, right? Look at this. A prime is here, A prime is also here, right? And what is common here? D prime is here, D prime is here also, right? So we keep the things that are common, right? So the yellow group will read as A prime, D prime, because B and C are changed. A prime is not changed, D prime is not changed. How about the green one? Along the row, B changes, right? So B is gone. And along the column, what is changed? C changed, right? Look at the circles here. C is changed, right? Because C is 0 here, but C is 1 here, right? What is common? Again, A is common here, right? And if you look at the top, D is common, right? So the green group will read as AD, right? So we found two different expressions for both two different groups. One is A prime, D prime, another one is AD. The next step is just to add it. That's my simplified expression. Okay, so what we do is, given an expression, we draw a table, we plug the ones, right? And then we make group of ones. And for each group, we get one expression, and then we add the expressions. We'll look at a couple more examples to see how we simplify the expression, okay? Because I think the most important part here is how to simplify the expression, okay? Meaning how to make groups and then find the expression for the groupings, right? Before I move on to some examples, these are the most highlighted and important things you need to remember before you start the Carnot map. Number one, Carnot map can simplify standard SOP expression only, okay? That means your expression must have to be in standard SOP. If not, you have to convert it to standard SOP before you start Carnot map. So that always works on the standard SOP. Number two, you can make group of 2 ones, 4 ones, 8 ones, or 16 cells of ones. Nothing different. Like you can make a group of 3 ones, or 5 ones, or 7 ones, or 6 ones, or 10 ones. You know what I'm saying? And you always will try to maximize the size of the group, not the quantity of the group. If you can make a group of 8 ones, just make that. Don't make 2 group of 4 ones. Okay? It has to be maximized by the size. And 2 groups can overlap, but even after the overlap, you must have to have something unique in the group, meaning there must be something new in the group. I'm saying it's not possible that you have everything borrowed from some other group, right? You have to have something different. Like you can have overlaps with other groups, but you have to have something which is completely new to the group, okay? Let me show you several examples of simplification. Now, what we did is we actually wrote the expression at the top, and then we showed the grouping at the bottom, at the Carnot map. Now I wrote the ones from those, right? If you look at this is exactly how I wrote it, right? Look at my arrows, so you can see how I exactly got the 1, right? From which cell. Now once I have it, I make the groups of ones. So this is actually separate, so this is just a single one, right? Now I make a group of 2 ones here, I make a group of 2 ones here, and there is an overlap. And as I said, there can have overlap as long as something is new to the group, because in each group there is something different, right? This is new to one group, and this is a single one, this is a one to another group, right? Then we have to do what? We have to write expression for each group, right? Look at the group at the top. This is just a single cell, so we write the expression A prime, B prime, C prime. This is a single cell, right? So you have to write all of it. Now for my vertical group, this is my vertical group. Look at the left side. What is changed? The A is changed, right? But the B is common, which is fine. B will be there. And if you look at the top, C is there. So the expression for the vertical group is BC. Look at this horizontal group. A is common, B is also common. So I wrote AB, but C is changed, right? If you look at the top, so that's why C is eliminated. So we have three different, expression for three different terms: A prime, B prime, C, and then BC and AB. So I added all of those. At the right side, this is my simplified expression, right? There will be several more examples. So this is another one, but if you look at here, we made a group of these two ones. We made a group of these two ones. But at the top, we have two ones here. At the bottom, we have two ones here. Remember the top and bottom, they are connected. The top side and the bottom side, they are joined, right? Because we think like this, they are wrapped up. So basically, we made a group of top ones and bottom ones. We made a single group of 4 ones. Because we always want to maximize the size, right? So we just made a group of 4 ones. And for that group, our expression is only B prime. Why? Look at the top group. We have A prime, B prime, right? And look at the bottom row, we have A, B prime. So A is changed, right? So A is gone. And look at the column here. This is C prime, this is C. So C is also changed. So the only thing that is not changed is B prime, right? So that is only B prime. I'm sorry. That is only B prime. For this vertical group here, A prime is not changed. So we kept A prime. And C prime is not changed, right? So that's why the expression is A prime, C prime. For this vertical group, A is not changed, right? But the B is changed. Look at this. B is changed, right? See, the B is 0 here. B is 1 here, right? B is changed, so B is gone. But the C is common. If you go to the top, C is there. For the whole group, C is common. And then we added those 3 terms. I'm saying 3 expressions for 3 groups, right? When you add, it doesn't matter which order you use. It doesn't matter. Okay, if you use any order. Here is another grouping to show you. So look at this. We actually made a group of 8 ones. Because remember, as I said, if you can make 8 ones, just make it. Don't split it. You have to make one single group because you just want to maximize it. And then you have a group of 4 ones here at the top. There are overlaps, but some of the ones are new, right? You have group of 2 ones here, and we wrote the expression for each of the group and add it. Okay? And then every time we just look at what is changed. If you look at these 8 ones, look at carefully. A is changed, right? So A is gone. But B is not changed. But across these columns for the C and D, everything is changed. Like C is also changed, D is also changed across the whole left to right, right? So that's why we did not pick C, we did not pick D. We just kept B as it is because B is the only thing that is not changed.
Do groups have to be in squares?
Yes.
You just put all of them together?
No. It has to be look like rectangular shape or a square shape. Groups always look like rectangular or a square shape. Group cannot be like anything irregular shapes. Group can be always square or rectangular shapes. Here is another example. So you see here group of 4 ones here, group of 4 ones here, okay, and group of 2 ones here. And we write expression for each group, okay. So these are some examples that shows you how to make groups because that's actually important, right? That to see given combination of ones how we can make different groups. There is another one. We actually gave you a lot of examples of ones so that you can see, I'm saying grouping, so that you can see how we made a group. Now what is interesting about this, look at this, we have 4 ones at the very left side, right? We have 4 ones at the very right side. And as I said, remember the left side and right side are connected, right? So we made group of 8 ones using that left side ones and the right side ones. So these 4 here and the very right side, these 4, we made a single group of 8 ones. Remember the left side and right side, they are connected, right? And the top and bottom, they are also connected. And then these 4, we made a single group of ones. These 4. And then these ones, we made a single group. Okay? So we have 3 group of ones. But I think one thing you probably may have realized by now, if your group is bigger, your simplified expression is actually smaller, right? Because you will not have, the more bigger your group is, you probably will not have too many things common, right? So that's why your expression will be simplified, and our objective is to find the simplified expression. So that's why we always try to maximize the size of the group instead of trying to make it make the number, right? Or d prime from the left side and right side combined. Okay, now let's look at this column here, okay? What is common at the, okay, now none of these are common from A and B, right? Everything changes. Now if you look at this column here and the rightmost column, what is not changed? C is changed, right? But the d prime is not changed. That's how we got d prime. See the d prime and d prime here? Because we are just, we took what? The left side ones and right side ones, right? Because they are connected, right? So only thing that is not changed is the d prime. But the C is changed, and across this, all of these rows, everything is changed, right? A and B, all of those are changed for this, all the 4 rows. Any question for this grouping?
Why is it for the BC prime square, why doesn't that just go over to the other side and incorporate CD into it?
So that means this one, are you talking about this grouping?
Why don't you shift it over to the side so it's too bigger?
No, are you talking about these groups or which?
That group, you're supposed to group them together as big as possible and overlaps are allowed to happen. So if the sides are connected, why doesn't that just run along to the other side and add another 2 spaces?
But you cannot have a group of 6 ones. Remember, you can have group of 2 ones, 4 ones, 8 ones. You cannot have a group of like 6 ones. If you go to the other side, you can incorporate another 2, right? But that will make it a group of 6 ones. There is no way you can add 6 ones. Remember, we can have 2 ones, 4 ones, 8 ones, and 16 ones. So if you go to the other side, you can incorporate these 2 ones, right? So what I'm saying is, I think if I understood it correctly, you said if I go to this side, meaning I connect these 2 ones, right? How many ones will be? 6 ones, right? You cannot have 6 ones. 2 1, 4 1, 8 1, 16 1, right? There's no other way you can make a group of ones. You always want to maximize it, but it has to be always 2, 4, 8, or 6, 16. So you cannot have 6 ones. Here is our last one. We have, in the quizzes you will also see some more. But look at these ones. There are only 2 groups. How we have only 2 groups? We just made a group of ones between these 4 ones at the left side and 4 ones at the right side. And these 2 ones at the bottom with these 2 ones at the top. There is only 2 group, right? Because you always want to maximize the size, and that's the maximum you can make. Any question about these groups? So that's why we just have 2 different expressions. And you see, the more bigger your group is, the more simplified your expression would be. Okay?
The order of when you simplify them, when you put them like d prime plus b prime c, does that matter in what order?
No. As I said, there is no it doesn't matter. Okay. So if you write b prime c plus d prime, it also works. Yeah, it's the same. Because that's because of the commutative law of the Boolean expression. Remember, it doesn't matter which order you write. It's exactly the same. As long as you make sure you write the correct terms, that doesn't matter. Okay. So for the simplification, since we need to learn these steps and try, and the practice, we actually have a couple of quizzes, which are chapter 4, quiz 23 to quiz 26. We have 4 quizzes on this part. So where in the first couple of quizzes we'll learn about how to plug ones, and then in the next ones we'll actually learn how to make the groups and write the expression given some ones, right, in our kernel map or K-map in short. So let me stop this so that we can work on our quizzes and labs.